How do we solve something like this? Well, there's two different ways to do it. The first way you could do is you could make these, give them an equal base. So they're going to be 2 to the 5x plus 1. And then we could change 8 to be 2 to the third to the x minus 1. Then that would be 2 to the 5x plus 1 equals 2 to the 3x minus 3, because we're going to multiply that out. Then you could have 5x plus 1 equals 3x minus 3. Now we just get everything all by itself, so we get 2x equals negative 4. So x, we divide both sides by 2, we get x equals negative 2. The other way we could do this is we could just take the log of both sides, because we don't always have to have an equal base. So if we just take the log of both sides, we're going to do log of 2 to the 5x plus 1 equals log of 8 to the x minus 1. So we get 5x plus 1 times log 2 equals x minus 1 times log 8. Now we're going to multiply these things in, so we get 5x times log 2 plus log 2 equals x log 8 minus log 8, because I just distributed both of those in. Now we're going to get everything with an x on the same side, so I'm going to get 5x log 2 minus x log 8 equals negative log 8 minus log 2, because I just subtracted, I took this over here and this over here, okay? And then I bring the x out, and I have 5 log 2 minus log 8 equals negative log 8 minus log 2. Then we divide both sides by 5 log 2 minus log 8. Okay, and so we end up with x equals that whole thing. And what you might think is that a lot of people think that they can now cancel out this log 8 and this log 8 and this log 2. You can't do that because these are across addition, right? We don't cancel across addition. So this is log 2 minus, or log 8 minus log 2 over 5 log 2 minus log 8. So let's just put this in our calculator. So we have negative log 8, close your parentheses, minus log 2, close your parentheses. So this is what's going to be on top, and then what's on bottom is 5 log 2, close your parentheses, minus log 8, close your parentheses. Okay, and so now we take the first one, we divide it by the bottom, right? That's the bottom, and what do we get? We get negative 2 and a little tiny 1 here, but that's because our calculator sucks at rounding. So it's negative 2. It's the same as what we got before in the other way. It's just another way of doing it. So let's take a look at a couple more. This one, we can't find a common base. They don't have a common base between 3 and 5, so we just have to take the log of both sides. So we have log of 3 to the x minus 2 equals log of 5 to the x minus 1. Now we bring our exponent down. X minus 2 times log 3 equals x minus 1 times log 5. Now we distribute, so we have x log 3 minus 2 log 3 equals x log 5 minus log 5, because we just multiplied this log 3 in, and we multiplied the log 5 in, and we get everything with an x on the one side, so we have x log 3 minus x log 5 equals 2 log 3, because I just added that to both sides, minus log 5. Okay, now I get my x outside, and I have log 3 minus log 5 equals 2 log 3 minus log 5. And then we divide both sides by log 3 minus log 5. Doesn't want to write. Log 3 minus log 5. Okay, so in the end, my answer is my answer is going to be x equals 2 log 3 minus log 5 over log 3 minus log 5. And again, a lot of people are going to be tempted to see, oh, log 5 on top, log 5 on bottom, log 3 on top, log 3 on bottom. But remember, they don't cancel, right? It's just like if I had x plus y over x minus y, those do not cancel out. Absolutely not. Remember, that kills kitties. We don't kill kitties. So these don't cancel. We're just going to put them straight into our calculator. So on top, we have 2 log 3, close parentheses, minus log, 2 log 3 minus log 5. Now this is what's going to be on top, okay? So that's our numerator. And then on the bottom we have log 3 minus log 5. Oops, I forgot to close my parentheses. Log 3, close parentheses, minus log 5, close those parentheses, because we want to just take the log of 3 or just the log of 5. Now we're going to go, this is our numerator. We're going to take that and divide it by our denominator, and we get negative 1.15. Negative 1.151. Now remember, we can check this if we wanted to. We could plug it back in and see if it worked. Let's try one more. So again, we don't have a common base for these, so we just take the log of both sides. So we have log of 7 to the x plus 1 equals log of 12 to the x minus 1. So we have x plus 1 times log 7 equals x minus 1 times log 12. So I have x log 7 plus log 7, because I'm just going to distribute that log 7 in, x log 12 minus log 12. Okay, now I want to get everything that has an x on the same side, so I'm going to end up with x log 7 minus x log 12 equals negative log 7 minus log 12, because I just subtracted from both sides. I'm going to take the x out, and I'm going to have x log 7 minus log 12 equals negative log 7 minus log 12. Okay, and then we're going to divide both sides by log 7 minus log 12. And again, everyone is always just so tempted to cancel here. You want to cancel out these things, but you can't. You cannot cancel across addition, okay? So if these are terms, you can't cancel them out. If you wanted to cancel something out on top and bottom, it has to be in every single term, okay? And since it's not, we can't do that. And the other thing you might notice is this looks really similar to this, but it's not, because this is negative, right? And so if I took a negative out of here, I would have negative times log 7 plus log 12, which is still not the same as on the bottom. So let's just plug this into our calculator. Negative log 7, close parentheses, minus log 12. So this is what's on the top. And then log 7 minus log 12. This is what's on the bottom. Oops. Log 7, close parentheses, minus log 12. Okay, so our numerator, this is our numerator, and we divide it by our denominator, and we get 8.220. That's our final answer.